In 2016, 5,600 participants across 42 countries took part in the event. iGEM is the premier international research competition dedicated to the field of synthetic biology. Ever since it was launched by MIT in 2003, more and more teams have been joining the competition, reaching over 330 team entries this year. For the first time in Greece, undergraduate students from the Aristotle University of Thessaloniki and the Democritus University of Thrace joined forces to create an interdisciplinary team which will participate in this year's competition. Student teams design, build, and test their projects over the summer and gather to present their work and compete at the annual Giant Jamboree in Boston, USA, which this year will take place on November 9 to 13th. iGEM teams are encouraged to work together to solve real-world challenges by building genetically engineered biological systems with standard, interchangeable parts. Each iGEM team sets a goal to create an innovative approach to answer major health, environmental, or social issues. Synthetic biology is an emerging interdisciplinary field that attempts to bring engineering principles into biology. Thus, iGEM Greece, as an interdisciplinary team, is composed of 11 students from 7 different schools, the fields of medicine, biology, molecular biology and genetics, physics, chemical engineering, electrical engineering, and computer science. Now just imagine minds from all of these fields combined together during brainstorming sessions. The ideas that came up, the solutions we thought of, the projects we prepared. In the end, we had to choose a project from a handful we came up with, and sadly leave the rest for later. And so we started. As the first college team from Greece to compete, we were engineering Pandora, a pipeline for the construction of modular RNAi-based logic circuits that act as cell type classifiers. In a sense, we're building a biocomputer that has as inputs molecules called miRNAs, the molecular signature of a cell, in order to differentiate, for example, a cancerous cell from a healthy cell. The signals then get translated into a desired output biological actuation, for example fluorescence for diagnosis or cell death for therapy. Colorectal is the third most commonly occurring cancer in men and the second most commonly occurring cancer in women. As a proof of principle, we're simultaneously working on developing a delivery module, a novel E. coli bacterial strain that can identify and invent colorectal cancer cells as well as eliminate them via the transfer of the classifier. After it's transferred, the biocomputer translates the signals inside the cancer into a cell death signal. Apoptosis is being induced and the cell self-destructs. Moreover, we're going beyond the lab, examining our experimental design in a social, environmental, ethical contexts. By organizing outreach campaigns, education seminars, we reached to a vast amount of people. We discussed our project with university students and showed them how everyone can create a project and get involved in it. We have expanded our vision further, sharing our wet lab work and software in an open source collaborative manner, collaborating with artists and professional dancers in order to intuitively nourish our idea to the general public through a dance, creating a wiki page where everyone with or without scientific background can explore our work, optimizing protocols to quantitatively integrate risks and safety issues, highlighted by experts in the field, in our project. In the end, iGEM Greece envisions a strong core of youngsters working together and combining their expertises to solve a major social problem through science. To ignite a spark in research initiatives by undergraduates, to boost entrepreneurship and create novel biotechnology tools to help fight cancer, to change the world one part at a time.